Okay, perfect. Well, I just initiated our recording. Thanks again for everybody joining today. Hopefully you'll find this to be a very educational session. Today's webinar, we're going to be starting to look at the 808D milling control, and we're going to be specifically looking at working with part programs that have been programmed through a CAM system, imported into the control. We're going to go through a bunch of different steps on handling them, and certainly CYCLE832. My name is Chris Pollock. I'll be your presenter for the next hour to an hour and a half, depending on how quickly we get through the content. I can be reached at this contact information. I'm a dealer support specialist with Siemens, and my territory is specifically the East Coast. But no matter where you guys are located, you can always reach out to me as a resource within Siemens. We've been doing these live seminars now for maybe a better part of 8 months to a year now, and just to kind of promote some of the ones that are coming up, I'm trying to make sure we can get a seminar out about every 6 weeks is what we're shooting for. So coming up shortly, beginning of March, we're going to have a program guide for turning. So this is going to be more 828 and 840 centric, and it's going to be specifically on controlling a lathe through a G-code-based program. Then after that, in May, we're going to do the same kind of content for 828 and 840, but it's going to be tilted towards milling systems. So keep looking for that. And just to make sure everybody's aware, these are this is our main website that I wanted to make everybody aware of. This is our CNC for You website. It's a great resource for looking for all kinds of information as well, either through the webinar link I have up here for you right now, or if you want to go to the CNC for You main site, there is a link that gets you right to this page. You can see what upcoming webinars are coming, and you can view all previously recorded webinars. As I'm recording this one now as well, the other ones get recorded. Please feel free to use it as a good resource for you guys. Send customers or colleagues to it to be able to gain more insight and information into the Siemens product. Okay, so specifically today, I mentioned just before, we are looking at the 808 control working with CAD/CAM-based programs. Once we start to go through some of the mechanisms of dealing with a CAD/CAM-based program, we're then going to even leverage our high-speed cycle, CYCLE832, to try to improve the performance of such programs. As well, in the 2.5D world, we're also going to get an opportunity to not only build a Siemens posted program, but what's called an ISO program. And in our world, an ISO program is like a Fanuc style program. So following more of their protocols as far as CAN cycles are concerned. So that's some of the content we'll be going through in this session. So first thing we're going to do is we're going to start looking at our G290 mode, which is what we call our Siemens mode. Generally, a lot of people don't realize it, but whenever you're in the Siemens protocol, and when I say Siemens protocol, it's just really what the commands are, how they affect the machine. You're actually running in G290 mode, so you'll hear me refer to it as G290 mode. Typically, you don't have to actually tell it to be in G290 mode. The system does it all automatically, but you could in your part program if you wanted to. So this is going to be the example we're going to look at first. So this is a little program that I created and posted out of Mastercam. It is a 2.5D cutter path, a very traditional type of scenario that we would see in a lot of applications. We're going to do some contour milling. It's where you see a profile around the outside of the shape of this part. Then we're going to come in and do a helical bore in the center of it with an end mill. And then we're going to spot drill and drill 2 holes in the part. When we get to handling the profile of the physical part, we're going to have it posted with cutter comp as a where type of function. You'll see that a lot in CAM posted programs. What that means is the actual output cutter path is already compensating for the radius of the tool. but you're still going to see a G41 or 42 command turning cutter comp on, so you can still adjust the resulting cutter path. And there's some challenges when you get to working with systems like that. So we're going to talk about it, show you a few different tricks, and apply that through. I do want to take a few minutes just to do a brief overview of the jog screen. I have gone through some of this content in previous webinars on the 808, so I don't want to spend a lot of time going to the detail because we have a lot of content to cover. But when you see some of the functions here, when we switch over to the ISO side of the world, you will lose some of these functionality. So I want you aware of what's here now. So when we do get over to ISO, you're going to see what the differences are in the control. So this is a few of the functions we're going to take a look at quickly, but we are going to take a look at measure tool, measure part, TSM screen. As well, we're going to go into the offset table. We're going to actually build some tools as we start to methodize the programs and take a look at some of the offset areas. From there, we're going to switch over to our program manager section. And this goes into the area where we actually manage part programs. So we're going to start transferring files in and out of the control. We're going to build some directory structure, create some file structure so we can copy programs in and out. I'll show you some tricks as to how to just kind of streamline how you methodize your parts and track your parts. From there, we're going to go into our event editor. This would be our G-code editor, and start to look at some programs. We're going to start to play around with a couple different examples. I have these scenarios posted out for you, and we're going to get to kind of see what the whole process is about in dealing with CAM-based programs. We're going to simulate it so you can get an idea of what's going to happen prior to running the system. And then we'll continue on, most likely even in an auto type of scenario. So with that being said, we're going to switch over to my SINUTrain seat, which is what's called 808 on PC. That is a machine tool emulator, and that's going to allow us to actually start to do some live exercises on this machine. So bear with me a sec as we switch over. All right, so everybody should have the 808 on PC SINUTrain running right now, currently. This is currently booted up in a 3-axis machine model. This is a fully functional simulator, so I can go as far as run a machine in auto if I wanted to. The system doesn't know nor care whether there's physically servos attached to it. So anything we do here is exactly the way it would happen if I was physically on the machine tool. Okay, first thing I did mention is that I did want to take a second and talk about the jog screen. The jog screen is what we're in right now. I can always tell I'm in jog because the jog light will be lit as well. In the upper left-hand corner, it'll tell me I'm in jog mode. Now within here, you're going to see some key functions that we use quite commonly in the setup of the machine. First is the TSM window. TSM allows us to do quick tool changes. If I want to change what tool is physically in the machine, right now I see that I have Q0, so there's no tool physically selected in the machine. If I want to fire up my spindle, turn on my spindle. So it really keeps us from having to go to an MDI type of protocol to be able to do some of these functions. I can go into measure workpiece, and this allows me to set zeros or set offsets. So I can find the edge of a part, I can find the center of a part, whether it be a block or a boss, and I can set zeros there. And these are very key functions when I'm starting to set up a machine. Same thing with the measure tool function. Measure tool allows me to set tool lengths on any given tools, assuming I had a tool set up in the machine. I do not currently right now. From there, we are going to switch over to the offset screen. In my offset screen, I will start to create some given offsets and start to establish different tools and different tool radiuses. Okay, so we have a couple tools created here. We'll start to go through, talk about those tools, play around with creating a few more new tools at this point. All right. From there, what I want to do is I want to transition over to my program manager section. Now I'm navigating through the different screens with this keypad on the right side of the display. You're going to see my mouse kind of hovering over it. So with that, I can navigate back to the machine area. That's my jog screen by hitting machine. I can go right to whatever program was last edited with this program button, or for what I'm doing right now, I can select the program manager button, and that's going to get me to the area where all of my part programs exist. Okay, so I'm going to go over to part programs, and we're going to start to come into the system and take a look at file structures and whatnot. Now you'll see that I have a few directories already created here. I'm going to delete them. We're going to kind of start from scratch a little bit. So I'm just going to go in and get rid of these couple directories. This way we don't cheat. We can kind of build everything from scratch. Okay. So we'll assume that nothing's been done in this control as far as file structure. So first thing would be, navigating and finding where part files maybe reside or lie. Generally, in the 808, you have a couple different ways to bring programs in and out. It will be determined as to whether or not it's an advanced system or a basic system. There are two different flavors of it. But what you have is you certainly always have a USB port. So that's what we're going to use for navigation and moving files in and out. This USB stick right here. RS-232 is available, and then the advanced system network capabilities are available as well. So with that being said, if I was to look at my USB stick, I have a folder here where I have some part programs, and I have a few different programs methodized. So we have an ISO or Fanuc-based program, and we have this Siemens-based program. This is that 2D profile. So what I want to do is I want to come in and I want to create a directory in the system, and then I want to copy in this part program to the machine. So back over under NC, this is our NC or system memory. This is everything that's residing internally in the control. I have an ability of creating either part program files or directories by selecting this new button right here under execute. So by selecting new, I can pick new directory, and I can type a folder name. And you can start to create different folders, and folders can be nested within each other. So let's say, for argument's sake, and I was talking earlier how I'm going to refer to things as G290, G291. I'm going to build a simple folder called G290. I type out the G290, I select the OK key, and it builds up a folder. From there, I can start to create other folders. Certainly I don't need to use folders. I can have part programs residing right in this directory. As you see here, I have an example one, this MPF file, main program file. But what I am going to do is I'm going to go into my G290 directory, and this would be the source as to where I want to copy that program to. So when moving files in and out of the control, it is very simple. You're just going to use your cut, copy, and paste commands. So I'm going to select the USB. I'm going to navigate into it. So I'm going to use my arrows when I'm on the machine to move my cursor around. I'll hit input to go into a folder. If I want to back up, I just want to be on this top folder. I can hit input again, and it'll back me up. So I select input. I drill down into this Siemens folder. I highlight my resulting program, copy, select my NC. It's going to leave me at the folder I was last in. So now I can simply hit paste. It moves the program into the part memory. So now, if I was to back all the way out, I'm back at the root directory. If I go into the G290 folder, I now see this part program. So let's open up the program. To open up a program, just simply highlight it and press your input key. And that's going to start me editing. So this is a very traditional G-code structured program coming out of a CAD/CAM system. So you're going to see a bunch of notes here at the top. So these are certainly very handy. So I have some tooling notes. I got a few different tools defined for me, as well as maybe posting time, source files, that kind of stuff. Then from there, anything below these semicolons, so all the semicolons are what we call comments. So anytime you want to put any type of user note in the program, just simply put a semicolon. Everything after it will be ignored. Then I start to see the header protocol, my tools, my tool changes, some technology statements, and we can start moving down from there. I see my spindle commands, different offsets, different things being fired here. So first things first, when I'm methodizing or setting up a new part to start to simulate and then eventually run, is I want to make sure that I have the appropriate tools created or set up for me in my tool table. So I see T1 through T4. So what I'm going to do, and I certainly have a little reference here on these tools, I'm going to go over to my offset table by selecting the offset key right over next to my machine and program button, and that's going to put me over to my tool table or my work coordinate table. Tool list is the tool table, work offsets where my part zeros are stored. Now I do have a couple of tools pre-created, but I'm going to build some new tools for you. Instead of cheating and using the ones that are here, I'm going to delete them and we're going to build them out. So right now I only have 2 tools in my library, tool 8 and 9, which are used later for a surfacing program we're going to look at. So in this case, when it's time to build a new tool, you're going to hit the new tool option. And these are your 4 primary tools you get within the 808 control to build: milling tools, drilling tools, taps, and ball end mills. So a milling tool would be a standard end mill, face mill, something along those lines. So in this example, I have a 3/4 inch end mill that's going to do my primary rough machining around my peripheral. Then we have a 3/8 end mill to do the helical hole in the center. And then we're going to use a center drill, which is 3/8, and a quarter inch drill to drill the holes. So if I select milling, simply type the tool number. Now this would probably be one of the first things you're going to see that's a blaring difference between the 808 and some of our more advanced controls like the 828 and 840. And that's the fact that in the 808, you only can assign tool numbers as names. When you get to some of the other controls, you can actually get a little more creative in your naming terminology. Once I've built the tool, I'm just going to assign some dummy offset to the length. Traditionally, this will get set by that tool length function we saw briefly earlier. When I want to set up my tools, it'll write to here. Then it asks for me for the tool radius. Now, I said it was a 3/4 inch diameter. If I want to cheat and not have to do the math externally, you can bring up a calculator on the 808. So on any input field, if you hit the equal sign, it'll bring up a simple calculator for you. So here I can tell it what I need to calculate. In this case, what's half of a 3/4 inch end mill. Hit my accept key, and it writes it immediately into the field. So you can use that certainly in a part programming area. Just remember, hit the equal sign, and it'll bring up the calculator for you. So tool 1 is in the system. Now I'm going to create tool 2. Tool 2 again is an end mill. I said it's a 3/8 end mill, so I happen to know that the radius on that's 187. And our length. I'm going to do a third tool, which is going to be a drilling tool, tool 3. Tool 3 in this case is a 3/8 diameter spot drill. So again, 187. I don't necessarily have to give it, obviously, the radius for a drill because there's no cutter comp associated with it, but I can. Sometimes it's nice from a reference side. And then I'm going to do a final tool, which is going to be one last drill, tool 4. And we said this was a 1/4 inch drill. So that's a 125 radius. And I'll just give it a simple tool length. Okay. So we have our base offsets set up for our tools. Now to jump back into my program quickly without having to find it and reselect it on the screen, I can hit the program button. This is a simple shortcut key, puts me right back to the program I was editing. So now we can start to look at the part program. So if we look at this program, we're going to start to see a few things right here in the beginning. We are going to see that this is going to do a tool change to tool 1. So it loads the tool here, physically loads the tool with the M6 statement. They have a corner rounding function initiated. Then we have some rapid, some basic header statements, what work coordinates using, spindle speed command. Now, you see this T2 right here? This is important to pay attention to, and this is probably one of the first areas where the way the post is set up can dramatically affect how your part programs work. The post I'm using here, and the post and the protocol that this machine is running from is really no different than an 828 and an 840. This is the same post that I actually use for 828 and 840 machines. However, this post was written for a machine that has a random style tool changer. So what this cheat code right here is doing is it's actually prefetching the carousel for the next tool. Unfortunately, this machine that we happen to be on is a carousel tool changer, meaning I can't randomly set up my tools. Well, you're going to find that depending on how they commission the machine, this can create some interesting results. So we're going to run this program, and then we're going to try a couple things, and we're going to notice that nothing's changing. And then I'm going to show you kind of what's happening here. But these are the things you're going to start to have to deal with when you're dealing with post processors, especially debugging them. A lot of times it's designed for one machine or one control. You're trying to apply it to a little different machine that was set up differently, and you may get two very different results. Okay, so if we go to simulate and we start to run this part, and I'm going to zoom in. You're going to start to see the machine come around. It's applying some form of cutter compensation. Okay. Now, this is this first area that you have to start to pay attention to when you roll around the cutter comp. What's happening right now, and what you don't know, which I already know because obviously I methodized all this stuff, is that we think that this machine should be running tool 1. Well, the way the parameters are set up in this machine, it's loading the offset based on the T code, not necessarily the M6. So one of the first things you might do would be say, well, what would happen if I went to tool 1 and I dramatically changed my radius to maybe a 0? What I would expect to happen when I simulate it is I would get a different result. But yet when I look at this profile, I'm still going around the exact same path. So no matter how I adjust the radius on this program, it doesn't seem to have any resulting change. Well, what's really happening is if I was to really run this part, it's actually loading the offsets for tool 2 because they have set this machine up to prefetch, but this actual machine isn't designed for prefetching. So watch what happens when I simply just delete this instruction that's not needed. Now, if we go to simulation and we rerun this part, now we see a completely different cutter path. So it's very important to start to understand how these commands build and understand that depending on the technology of the machine I'm on, they may function very differently. Okay, so what I really wanted to start to show you here, and this is very common when dealing with a posted program where they're compensating for the tool radius already. Let's run this. So right now, I have the tool offset, tool 1, set up at a 0 cutter radius. So this would be the actual cutter path I would need to cut this part accurately. So if I put any offset in here, so let's say I put it back to that 375 radius, because it's a 3/4 inch end mill, now as I start to run the program, and we cycle start it, now you see how it's pushing the compensation out. Now my part is now oversized, and it's oversized by that radius. So we see this is center line of the cutter. So you want to be careful when you're posting programs that, how do I handle this? Well, you got a couple different ways to handle this. Certainly, probably the most common way when dealing with programs that they want to have some ability of adjusting an offset out of the machine, it's called outputting from the cam side, outputting where, is it's still going to output a 41 or a 42. I can see my G41 is here. We always hide it on me, right there. So there's your G41. This is what's turning on the comp. If that wasn't there, this issue wouldn't occur. But since the 41 is there, I either have to set up my tool with a 0 as my radius, and then as I adjust it, I can put maybe a small adjustment value here, and then as I simulate it, I'm going to get a new cutter path just off of that. So now you see, I'm going to zoom in for everybody so you can really start to see it. And let's move over a little bit. I want to get right in here. All right. So now I see, all I did was, in this case, I put 25 thou, a little larger than I would in real life, but I wanted you to get a chance to see the different cutter paths. So normally, this is how most guys run their machines when I'm dealing with CAM, and I'm outputting cutter compensation. They establish all of their tools at 0, and they'll put small incremental values here, plus or minus. You know, like if I was to set this value to a negative 25, I'm going to now see the exact same path, but now there'll be a new line on the right side here. So there's our new line on the right, just my compensation. And that's certainly a valid scenario to run your machine, and now you still have adjustability if your parts aren't coming perfectly to size without having to repost the whole file. If you didn't have cutter compensation on and you need to change it because an end mill was undersized or oversized, you would have to repost the entire file and bring it back down to the machine. Now, what if we want to have an operator put the correct radiuses here, but we don't want this double compensation we're seeing? Well, within the Siemens control, we have a neat little feature, and we have the ability to modify offsets within a part program on the fly. So what I'm going to do, and I'm just going to put it just somewhere just below my tool change, is I can do a statement called TOFFR equals, and I'm going to put a negative whatever the radius value is. So TOFFR sounds a funny kind of statement, but really what it is tool offset radius. So we're adjusting the tool offset's radius. I can use this as an L, TOFFL, and then I can adjust the length of an offset. So what that's doing is it's saying, okay, I understand you're telling me I got a 3/8 tool, but in reality, I'm going to take that 3/8 away before I run the cutter path, but you still have cutter compensation. So if I simulate that same part program, I'm going to delete the window so we'll get a fresh simulation. I'm going to see the same results as I would have had before. So I'm not getting double compensation. This edge of this part would have been at 2 inch. That's correct. And now I can just add or subtract to this diameter like a real world scenario. So if I think it's a couple thou over or under, I could put the true value here. So let's say 0.4. I'll put a big number, for instance. And I run it. And now I see, like we saw before, I get that simple 25 thou offset. Same token, I could come over here and put 0.350. Jump over to the program, cycle start. And there you see the offset. So it's just a nice, simple little trick when dealing with programs with compensation. Whether you use 0 offsets in the tool table, quite common, very acceptable, or use true offsets. I like using true offsets in the table. I think it makes it a little easier for operators. You know, if you're setting up a half-inch end mill, put 250. And this way, if you know you're doing regrinds or it's undersized or oversized, you can put that true amount, and you're not always kind of guessing. So this would be the trick, using the TOFFR statement. Now, what I do also want to show you here towards the bottom of the program is CAN cycles. So this program drills a couple holes. So now, when you're dealing with CAM systems, the system itself, we'll go down a little bit further, go to our first spot drill here, you see it right down here. The system's going to output a CAN cycle. And this is how CAN cycles look in the Siemens world. So you have an MCall statement that sets up modal drilling, and then you have a cycle 81. I go down a little further, you're going to see a cycle 83. So it's just a different type of drilling cycle. Well, when you're on the system, even though it was posted from a CAM, as long as they're using our CAN cycles, you can actually launch what we call the data mask. And what the data mask is our controls automatically have conversational programming built into the cycle level. So I can open up the cycle, validate, or maybe make some changes like, hey, I want to change the depth of my spot drill because it was a little shallow, without having to go through and repost it. If you're always letting the CAN system put out point-to-point and not use any CAN cycles, then you start to lose the ability of making quick changes at the machine tool. So here, I could simply say, hey, I want my spot drill to go -0.2, accept it. It updates the appropriate field in the cycle. That would now apply as I run the program. But the other thing you're going to use this for is for debugging of posts. Probably the most common mistake that you're going to find a post that gets written is going to undergo in the system, in the world, is how they build our CAN cycles. So what you're going to do is when you're first checking out that post and validating whether the post is correct or not, you want to have them build up a bunch of CAN cycles. And then what you're going to do is you're going to open the CAN cycle, and the first thing you want to look at is how many blank spaces are here. Some blank spaces are okay, but that usually tends to throw up a red flag that you want to pay close attention because they probably are not filling out all the variables. So then I would just simply go through the actual resulting cycle and validate that it's all correct, that the depth was in the right field. Because if they built the placement wrong when they post it, like, oops, we were off a position, so we put the drill depth of 0.6 right here, one place down, so now it's affecting a reference plane, or maybe I moved it up and all of a sudden my drill depth is under my safety distance field. Those are the things that are going to get mistaked initially when you're first building a post processor. So use this mask as a quick way to not only obviously modify the program once you're in production and making parts, but validating that the output code out of the CAM system is good in the first place. Okay. So now I create a part, I'm ready to run. From here, when I want to run a program in the 808, I simply hit the execute button, and that's going to automatically put me to my auto mode. I could run the part from the beginning just by simply hitting cycle start and letting the system run. Now, we do have what's called real-time simulation or real-time graphics. So if you hit the real-time simulation function, I'll put the auto zoom on and delete the window. I can see real time as the machine's running. You crank an override down and it stops. The graphics would stop, start back up, machining out my given part. Now, two features I'd like to show you real quick. One is how do we pause midstream of a part program, maybe pull away, check some dimensions, clear some chips, and return to that point and continue cutting. And the next would be how do I just randomly start anywhere within the part program that I want. So within the system, while I'm running, so I'm going to crank my feed rate override down, give me some reaction. So the machine's running, it's cutting, it's doing its thing. I need to get in and check something. If you simply hit cycle stop, the machine will pause, and I now have the ability of going to jog, moving the machine up and away, getting it in a safe position, doing what I need to do, and now actually retain the point at which I stopped. And I never at one point hit reset. See, it's still in a cycle stop state. Don't hit reset. If reset will clear it, it'll lose that point that it stopped at. But as long as I'm still in the cycle stop condition, I can simply go back to my auto screen and watch what happens here. I got the crank down. It's going to vector. So it's going to go shortest path to the point at which I stopped and then continue cutting. So simply hitting cycle start would reposition that cutter right back down, picks up that point, and continue machining. And you can do this as many times as you like through the run of a program. You can keep pausing and restarting just by cycle stop, hit jog, jog away, come back in. Now, what if I need to start somewhere midstream of the part program? Very common. We were running, we got through an operation, checked that up, it's all good. Now I want to move on to the next operation, but I don't want to start from the beginning again. You're going to use what's called a block search. So in block search, I now have the ability to come in and see my part program. So I can page up, page down, move wherever I want it to start within the program. So let's say I need to start drilling. So I'm going to come down to the drilling, but I'm not going to start from a safe point, meaning I'm not going to start from my tool change. I'm actually going to start from some position after my tool change. This is pretty common, but this is very difficult to do on a lot of controls because they only want to start from a point at which it's going to have all the modal commands after that. Well, within the Siemens control, you can start from any location you want. So I'm going to come down. Well, what I do want to do is get rid of this tool for call because that is not valid. So I'm going to start, let's say right from here. Now, I'm simply going to tell the system to do either to endpoint or to contour, and it'll calculate to this point, set up all modal commands, and start from this point. Now, the difference between to contour and to endpoint, to contour wants to try to do like a lead in. To endpoint is just going to go straight to the point at which I'm at and start cutting. So you select to point, in this case, to endpoint. Now I can crank my override down, cycle start. It's a 2-cycle start hit. First cycle start gets it set. Second cycle start starts me at the program. I'm now down and running, and it finishes up my program. So you can start anywhere you want within the control just by doing that mechanism. Okay. So what we're going to do now is let's break for a second because I do see a couple questions coming in. Can I search by a block? Yes, you can. When I did that search command, I have this search field, so I can type in actually anything unique here. So if it was a T code I wanted to type in or a block, I can certainly put that in. Another question came in just before. How many jog moves can I do before I restart? As many as you want. There's no limitation, at least that I know of, as far as number of jog positions. But remember, the system is going to vector to the starting point. So make sure you leave it in a safe spot where it's going to go shortest path. It's going to do potentially up to a 3-axis move to get there. So it's pretty common to move her away and then jog her back kind of close before you restart the system, so then that vectored position isn't that great. All right. There was another question that came in a little earlier. Regarding 808 on PC, the software I'm using is fully available for download. You should be able to get it from our CNC for You website. It's completely free of charge. You have to kind of sign up and then register for it within the system, and once you have it indefinitely, and it can be completely used to actually program these machines from it. Okay. Great questions. We will do a Q&A period at the end as well for any other questions that may come up. Okay. So what we're going to do now is we're going to switch back over. Oops. I wanted to go back to my PowerPoint. Sorry about that. And now we're going to start to look at the ISO mode. So we're going to use the same part program that we just did, but we're going to switch over to ISO mode, and then we're going to get a chance to kind of see what we get, what we lose. So first step, whenever switching the control over, is you're going to have to go into system parameters. I'll show you how to do that. We have to set our password, and then we have to tell the machine to really repower up into the ISO mode. And this is a little unique for the 808. When you're on an 828 and an 840 control, you don't have to go through these steps. You can actually switch between the modes on the fly. But the 808, you specifically reboot into the given mode. From there, you're going to see some functionality is going to change. So that's why I pointed out a few of those screens, like the TSM, like the measure part, measure tool. They are not available when you're in ISO mode. We're trying to make this kind of run more like an ISO-based program. So if you were to need to do a tool change, you'd have to go to an NDI screen. If you were setting an offset, you'd actually have to physically write the offset right into the offset table. Okay. There also will be some changes to the offset table. We can see that here. There's a new H column you see kind of circled in red there that's going to get popped up. Reason being is when you get to ISO-based programs, they call up the tool height separately from the T code, and there's a G43H number. That has to correlate to an H column somewhere. So this is part of the reason why you reboot the system, because it actually activates this type of functionality. Then we're going to go in and we're going to look at the part program. And for those of you that are experienced with ISO or Fanuc style programs, you're going to see this is really posted directly for a Fanuc machine. No editing needed per se, just no percent signs, and you want to just comment out the program number. You don't need the program number. Other than that, it's a direct drag and drop into the system. We'll simulate it so you can see the simulation functionality. And then we'll even go over to run, just you can kind of get a feel for how it runs and what it looks. It's not like it's parsing it into R's or doing anything funky. As far as the operator is concerned, it looks like it's just running the straight ISO protocol. Okay, so let us first learn how to switch the control. So what you need to do is you need to go into the machine parameters. So remember, we've been using these buttons in the upper right-hand corner: machine, program manager, program. We're going to see a button called alarm. And above alarm, in smaller text, it says system. Well, if I just hit the alarm button, it's going to bring me to the alarm screen. So any alarms that may be there within this system can be viewed within this screen. But if I hold the shift key down, now instead of going to alarm mode, the same button is going to go into the system parameters area. And this is how you need to get to the ISO switch. So you want to hold your shift key down, select the alarm button, and it's going to put us over to the machine configuration area. Now, what we're going to want to do is we're going to hit this ISO button. But you're going to see by hitting it initially, it's going to say that you don't have the access level to switch the control. This is dependent on access. So it really keeps an operator from inadvertently switching it, if you don't want a guy to be able to do that. So what you have to do is you have to set your machine password, your access level. So right in the upper corner on our screen, you see a set password function. Select set password, type in the password sunrise, S-U-N-R-I-S-E. Type it in, hit accept, and you're going to see that it switches the access level over to manufacturer. So once I'm at manufacturer, I can now simply hit the ISO button. It's going to warn you it's going to do a reboot. I say OK. The system's going to reboot. It's now powered up into ISO mode. I see this little red ISO symbol. Now the reference points up, and that's because this machine has incremental encoders, the one that I happen to be on right now. So it is wanting me to just re-reference the machine once I've switched modes, because I did, all intensive purposes, repower up the control. So I'm just going to do a quick referencing procedure. Machine's now homed. If your machine is equipped with absolute encoders, the advanced systems can be, then you wouldn't obviously have to do that. I am going to set it in metric or inch to switch the control on either mode between metric and inch. Just hit the settings button while I'm in jog. And then I hit this button right here. OK. And it puts me to inch mode. So now I see 4 decimal places telling me I'm an inch. I'm now set up. So I said it earlier. I showed you a pic on the PowerPoint. But here you can start to see a bunch of buttons are now missing. And that's because you're in ISO mode. You have the ability to set relative zeros. But if you want to actually write to any offset tables, you'd have to physically go to the offset table, go to work offsets, and enter what the offset value is. And that would be the value right here, this machine coordinate system value. Same thing with tools. Now, what you do get, and which is very important, is you get the H column. The H column is required to be able to start running the part programs. So the way the H column works, and you'll see it in the part programs as we open it, is it's generally matched to whatever the tool number is. So if it's T1, it's going to be H1, T2 is going to be H2, so on and so forth. It doesn't have to be, but usually that's typical standard. So I'm going to set up my H's now while I'm in this screen. Keeps me from having to do it later. And we'll set up H4. OK. So from here, we're in the mode. I can go over to Program Manager. Now I'm going to want to come back. I'm going to create another directory like we did earlier. I'm going to call this my G291 for ISO mode. So for all intents and purposes, maybe this is where I keep all of my ISO-based programs. I'm going to go over to my USB stick. It's the same exact scenario like we did before. So navigate to the appropriate folder, highlight the program, copy it, go back over to NC memory, paste it into NC memory. OK. From here, we can open up the program. So navigation, everything stays identically the same between both modes. So you can bounce in and out of them. You don't have to relearn the controller or anything. But what you will notice is when we're running ISO programs, we're a little bit more liberal on format extensions. So like here, Mastergram likes to post programs with a .nc extension, numerical control extension. I didn't have to rewrite this to an MPF extension in this control. I was able to leave it at NC and it would still allow it to fully run. You know, traditionally your G290 programs, your Siemens programs, would have a .mpf standing for main program file. Okay, so we go in, now we start to see what the part program would look like. And this is very, very typical. G20, this would be inch mode in the ISO protocol, G17, G40, 49, standard header statements, G80. Tell it to do a tool change. We have a tool change protocol right here for you. We have some other fields like, you know, absolute, setting up our spindle commands. So this would be what you would normally set up. Now here is your G43 H offset. So here we see H1 being called out at this point. If I was to maybe search down to the next tool, which is a tool 2, now you're going to come down and see the G43 H2 field. Okay. And then so on and so forth, right down through the part program. Now, if we keep going down, just to show you, we can go down to our drilling cycle and show you this is your standard drilling cycle. There's your traditional G81, Z-sum depth, R, feed. So this is a direct dropout. There's no editing needed. Like I said, just get rid of your percent signs if you have them in the program, and no program number at the beginning. Other than that, you can start to run it right here. Okay, so if I want to start to simulate programs that are run, I can do it the exact same way I did before. I can jump over to simulation. We're going to delete the window here, start from scratch. I want to be in auto mode when I'm simulating, hit cycle start, and then away she goes. Now, here I see I get this heavy offset. I don't see my nice big arc. That's because this is double compensating again, like we saw earlier. This program was written, let me jump back up to the top so you can see it. This program was written for cutter compensation with wear. So if we come down here right to line N170, there's my G41 cutter comp line. Well, because of that, just like we saw earlier, if I have a radius here in my tool, it's going to try to use it. Now, unfortunately, I do not have, that's not happy. I do not have the, do that. Each number does not exist. Love PCs. Okay, let's just try to simulate it real quick. I do not have the ability, and I'm going to have to reset this. Okay, bear with me 1 second. I just want to shut this machine down and relaunch it. I do not have the ability of doing that radius trick that I was showing you before on the Siemens side. You know, those upper level instructions or functions are certainly things that are reserved to when running in R mode. So, you know, those are that and a lot of other commands. As you start to get more in depth in the control, you start to lose when you're in ISO mode. So just be aware of that. Be aware that, you know, you are going to compromise or give up some functionality or features when running within this mode. So let's just jump back in. I wanted to just re-simulate that for you. Excuse me for having to reset the machine. It's a PC, gotta love it. Okay, so I come in, cycle start. Oh, put it into auto mode. And now, if we zoom in, now we see our fluid sweeping arc. So be careful with that. In, you know, ISO-based programs, when I'm putting on cutter comp and I've already compensated for the tool, I do need to set my tool radiuses at 0, or I'll get double compensation, just like we saw over in the other side. Now, as well, running the program is exactly the same in either mode. So simply select execute, cycle start, It'll start running that program. I can do block searches. I can stop midstream, just like I showed you. All that functionality still exists. You still have the concurrent graphics. You still have all that functionality available for you when you're in ISO mode. What I would probably recommend if you're going to try to leverage the machine in this mode quite commonly, you're probably going to find you want to do most of your setups because you have all those extra tools, the measure tools and all that available to you, which are great features. You're probably going to want to do all the setups while still sitting in our standard G290 mode or Siemens mode, and then just simply switch to ISO mode when you're ready to physically run the part program. Okay. So that's a quick overview of the ISO mode. What we're going to do now is we're going to switch gears a little bit, and we're going to start to look at a little bit more higher technology type of features or functions. So we're going to, let me just shut this down for a sec. We're going to go back to our PowerPoint, and we're going to keep jumping into the wrong one, excuse me. We're now going to start to talk about what I call 3D surface machining. So in this scenario, we're actually going to take a part that was machined as a three-dimensional surface file, and we're going to start to play around with it and show you a couple different ways to utilize those programs on the control, give you a couple little tricks as to how to work with those types of files, because they can be pretty substantial. So we will want to, certainly get a chance to start to see some of this stuff. And this is definitely areas where we're going to get in and start leveraging some of the advanced functions, high-speed cycle for one, for our argument's sake. So what we'll be doing here is we'll be going in. I'm going to show you first thing we're going to look at is what you traditionally see coming posted would be a large program file, has all the operations in it. So all the operations will be contained in one program. And we're going to, I'll bring it into the control, but the file is so big that it may potentially not fit in your control. So I'm also going to show you how to execute it from an external device. So we're going to look at it two different ways. We're going to look at some common posting errors as well. We're going to look at some normal posting issues, just as, like I was showing you earlier with like T-code, the way that was applied wrong. Here you have some older technology cycles that are being triggered. So we're going to talk about those a little bit. Then I'm going to start to show you what's a little bit more progressive in the industry, but it's a way of managing these more complex part program files in a subprogram main program structure. So I have it pre-created, but what you would normally do is have built a simple main program structure out at the machine, and it'll call up, and each of your operations, so in this case, I have 3 separate operations to machine this part. I rough it, I semi-finish it, and then I finish it. And I'm allowing the main program to bounce between 3 separate smaller files that contain really just the cutter path. You're going to start to see this becomes more and more popular in the industry as ways to deal with large files, large file structure. Then we're going to start to use some kind of unique statements. I'm going to show you how to use some R variable statements to be able to pass data from one program into the other. So in this case, I'm using it for my feed commands and my speed commands, so I don't have to ever go into the subprograms and make any editing changes. I can actually edit them right from one simple point in my main program, and the results will affect me in the sub. And we're going to start to use go-to statements for quick jumps in navigation. Certainly I can use the block search function. It's a great and powerful function for doing this kind of stuff. But you're going to find go-to is also a very, very powerful tool to be able to move around through programs really, really quickly. From there, we're then going to start to look at our high-speed cycle and play around with the high-speed cycle a little bit. I certainly want to run the program, come up with a baseline cycle time, and then show you kind of what's going on. Now, when using CYCLE832, our high-speed function, let's take a minute and talk about it. The interface screen is pretty simple. So you're defining a tolerance, and that's what's called a chordal tolerance. So I'm going to show you what that is in a second in the next slide. And then you're defining through the TOLM field, really just the technology. Are we roughing, semi-finishing, or finishing? From those 2 statements, all kinds of back-end things are being done. In the more legacy-based controls, you used to have to either program a lot of this stuff discretely, and we would find inconsistent results on the machine tool because a lot of times guys were just triggering the wrong cycles and didn't know when to leverage which cycle and which. So we've taken a lot of that out of the scenario by putting it all in the back end, and you just tell us, hey, are you roughing, you finishing, you semi-finishing, what's the tolerance? And then this way too, we don't deal with cases where the guy's calling up a legacy cycle and should be using a newer one. So this kind of takes care of it. But what's being triggered in the back, some of, and not limited to, but certainly some of the key functions, is first the compressor function, and we see that in the upper left-hand corner. And this is also a good slide that starts to talk to you about what the chordal tolerance is, that 5 thou tolerance I had before. The tolerance is really a value that gets passed from the CAM system, and it's really how far we allow the point that's being output in the part program to deviate from the original curve of the piece. So if you can, you want to use the same value that you're using over the CAM side of the world over here. It's just going to make everything be a little bit clearer. If you don't know what it is, usually the standard rule of thumb, at least starting out, if I'm roughing, I usually put about a 5 thou chordal tolerance. If I'm semi-finishing, I typically drop that to a thou. And then if I'm finishing, I usually set that to half a thou, 0.0005. That's at least the starting point, and you can play with it from there. Move it up, move it down. But if you know what that value is, that discrete value, you would want to give that value. Now, what is the value really doing? Well, what it does on our end is in CYCLE832, we're turning on what we call a compressor. And what a compressor really does is it's taking these point-to-points that you just gave it in this part program, and we're transposing a spline or a curve through all of these points, because what we're trying to do is we're trying to figure out what the original curve of the part was in the first place. CAM systems have a hard time outputting splines, but yet the data they're storing in their system is actually a spline. And they had a hard time outputting them because typical controls could not read splines. So they had to put everything into these point cloud type of scenarios. So what we're doing is, for all intents and purposes, we're really reverse engineering your part. We're transposing the spline through these series of points, and your chordal tolerance is really the restriction as to how free we can make this spline to try to figure out what the shape was in the first place. When we run the actual spline. Other commands that are getting stated is like G664 or G645. These are look ahead and corner rounding functionalities. We have our feed forward commands will be being turned on or off with our jerk limitation functions. Feed forward soft, feed forward brisk, there's a few different technologies. This, as well as a bunch of other stuff, is everything that's being turned on in the back end when you start to utilize CYCLE832. Okay, so what we're going to do is I'm going to fire up my machine again. So let me just share that real quick. Okay, so we're back into the machine, and we're going to start to look at some of these programs and play around with them a little bit. So first things first, I'm going to navigate over. Now, I switched it back. That's what I was doing before when I shut it down. I switched it back into the Siemens mode because this program happens to be methodized in our G290 Siemens mode. So we're just going to jump over to our program manager, and we're first going to look at the complete part program. I had it sitting in here, so I'm just going to delete it for now, and we'll bring it over. Okay. So remember I said there's kind of two ways. Old school, or probably most common in the industry, is to physically post the entire file as one program. So in this case, it is about a half a meg file. Not too big, it's not too big a surface, but these files get big really quick. And they also become pretty unruly as far as to navigate them. So we're going to bring it into memory first. So I'm going to copy and I'm going to paste it over. I'm just going to put it in the root directory here. So there is this surface program, so same kind of method, assuming it fits. And now we're going to open it up. We're going to start to look at it. So when I start to actually navigate through this program, I'm going to start to see that it's big. It's really big. I mean, I can keep going and going and going, trying to navigate through this program. So if I have to do any editing changes, if I need to validate anything, it becomes pretty tricky. I have to navigate all the time. I have to use my searches to try to move around through the program. Okay. So if I start to look at the program, I start to see a few different features. One of the first things I want to point out and show you, and you kind of saw this command a little earlier, is this G641 ADIST equals. Now what that is that's actually a pretty old command. And that's the corner rounding function that I earlier talked about just in the last slide we looked at with the G645. G645 is just a newer version of this function. We are always what's called upwards compatible. So what that means is we always want to allow programs that were written for an older machine or older control to be able to run in the new system. So we never get rid of commands, but we don't want to change the functionality of a command all the time because that can get a little messy. So sometimes we'll just build a new cycle. So originally we had G64, then we went to G641, and then we had a G642, and now we're up to a G645. Well, right now I see this cycle. What that tells me is this post probably hasn't been updated in a good 10 years because we have had higher level cycles in G641 for easily 10, if not 15 years. So this is very common when dealing with post-processors. And this is part of the reason why sometimes it's nice to just not even have them deal with the technology tied to the functions. You know, as a control manufacturer, we're adding things all the time to the controls, and a new control comes out. These guys are playing catch-up all the time with these posts. So if you start to kind of follow the logic that I'll show you next with breaking up the part programs, then certainly it makes things a little easier. They don't have to worry about making sure everything's up to date. Okay. But if I wanted to navigate through, I need to start using my search functions. You know, maybe I wanted to get to tool 9, so I could search down to tool 9. You see we're already at block number 9600. There's my ball end mill. But again, see these old statements are riddled through. So if I'm going to have to start editing and modifying them, now I got to jump in all kinds of different places throughout this program to make sure I get them all. Now, if it's a complete program, I can still utilize it the same way. So certainly you can go over to simulation. I can simulate the cutter paths if I wanted to see what's about to happen. I can look at it in different orientations. So we can maybe look at a front view if I want to see what's happening. We have a 3D view, a 3 view, shall I say. We're just looking at it, a quick little top view here. So now we're roughing it out. System would come over, roughing out the contour, and then we're going to finish it in the other direction. This is just has a much finer step over. It's using a much smaller tool to do its final finishing path. So certainly surface files can be simulated just like you could simulate you know, the standard files as far as 2.5D files like we saw earlier. So this is nice because at least I know if there was some kind of crazy syntax error in the middle of the program or something got posted funny, I would see an alarm right now. I would know what's going on. If I want to run it, I could simply go over to execute, cycle start, and then all the features we saw before, starting in the midstream of the program, I can do any of that kind of stuff. Now, what happens if that program, this large file, doesn't fit in my system? So let's say, for argument's sake, this is the scenario we have today. So I am going to delete the program. So on the 808, as well as our other controls, you have the ability of running programs from any external surfaces, you know, external memory allocation, shall we say, or devices. So just like that, I can be sitting on the USB. Now, limitations to the 808. For one, I can't edit the file while it's on an external device. So if I hit the input key or I try to open it any which way, it won't open. You would have to, if you needed to make any editing or modifications, do it externally. But what I do is I use this external execution button right here. And that's what's going to put the system into memory. It's automatically going to switch me to auto and get me ready to run. So this right now, and as I hit cycle start, This is physically running off of the USB stick. You do have to remember that procedure, however. You got to make sure that you go Program Manager, highlight the file wherever it exists. It could be on a network drive, it could be on RS-232. Hit the execution button. External execution is what it stands for, EXT, execution. And then cycle state start, and start running the program. Okay. So now what we'll do, though, is now we're going to switch gears and look at methodizing this part with a main program, subprogram structure. So what I've done is I've already set up on my USB stick a folder structure called surface machining. And what it contains is it contains, in this case, 3 different operations that I'm going to use as subprograms now, and a little main program that I wrote. So what I'm going to do is I'm going to copy my folder and paste it over here. And I get my surface machining folder, and it brought all of the files in the subfolder with me. So I can grab large chunks of data, bring them over in one shot. So I'm going to leave it in NC memory just so we can kind of come in and out of the files a little bit. So what does the surface program entail, or the main program, shall I say? Well, I'm going to do all my tool changes in here. I'm going to set up my high-speed technology statements here. I'm going to call up whatever the programs are from here. I'm going to do my safe retract acts, my shutoffs, all that gets set up in the main. What I'm really leaving the part program up for, which now is a subprogram call, that is simply going to be my cutter path, allowing the CAM system to do what it does best, which is output cutter path. So one of the first common things that's always a challenge is how do I deal with speeds and feeds? Certainly I could have my speeds and feeds up in this main program area, and I could have totally left them out of the subprogram. And I'm going to open up this first roughing program so you can see. Or what I have the ability of doing is I have the ability of leaving the speed and feed commands in the program. So if I scroll down here, I'm going to get to my speed statement. There it is. There's my S. And instead of having an S with an RPM, I can always substitute an equal sign and an R variable. Now, this R variable, this is going to get written to one of 2 ways. First is going to be if the main program is setting it. So what I was doing before in my little program is I was right here with my R30, so I'm telling this thing I want this thing to run at 4,000 RPM. If there isn't any values, any R values set up in your part program, what the system will automatically do is go over to the offset table, go to its R variables, and look for R30 in this column. So if you don't want your R variables in the part program, maybe you don't want operators going in and editing that, you can have them go to this column right in the offset table, and they can write them right here. But it's always going to utilize what's in the part program over what's sitting in this table. So this is only a secondary if it doesn't get written anywhere else. So as well, I did the same thing for feeds. Here you see we have some R's, R20, 21, 22. If I go back into my roughing program, it's mimicked in all the other operations. Now I'll get down to the feed statement. Right there, here's my feed, F equals R20. It's that simple. And you can use R variables in the middle of CAN cycles. You can use them all over the place. So play around with them. Feel free to kind of manipulate them a little bit. Now, a couple of the other modifications I did in turning this into a subprogram is I commented out. I could have deleted, certainly. I commented out all tool change commands because I want to do that up in the main. I don't want to have nested tool changes. I commented out any kind of advanced technology cycles, corner rounding, feed forward functionality, anything like that. I don't want here. I want pure cutter path. Whether I want the spindle and feeds is really up to you. I'm not that concerned because I'm passing them through with R variables. But you don't want to have operators have to go into the subs to make any editing changes. The only area they should go into, if any of them, would be certainly in the main program file. So I just commented out these lines. If this was a real part that I was going to do in production, I would just delete them. No need to see this kind of stuff. And then from there, the part program It's a matter of setting up my normal header statements, G90 absolute, G94 inch per minute, G17 is your standard XY orientation plane, G700 is a metric mode. I'm using my SUPA statement. This is a rapid retract statement, so it suppresses any work coordinates, cancels my tool offsets. That's what the D0 statement does. Puts it into a rapid mode and tells the machine to go away. Any of this stuff, if you're not familiar with it, I certainly recommend go back to my earlier 808D milling webinar I did a few months back. We go through all these commands in a lot more detail because we actually write a live exercise. Work coordinate, whatever work coordinate you want to use. Now, I can use this go-to, and we'll use this in a little bit to jump around a little bit. We talked about that one. Then I do a tool change, load my tool. Now, you see, I like to put this D1. This is what tells the system what offset I want to load. You don't have to. Earlier, we saw they weren't using the D command because the system will automatically load based on that T command if the parameters are set up that way. That was why we actually had the problem we did with the prefetching, because this one's machine set up to load tools on the T code, but once you put another T code in, it supersedes the last. Okay. Tool change. Now there's our CYCLE832, and we'll start to play with this here in a second. And then this right here is how I physically call up my subprogram. So the system is smart enough that if you just give it simply the name of the file, so op1_rough. If I look back up here, op1_rough. Don't need any extensions, nothing. So just simply give it the name of the file. As you see it here, op1_rough. And the system will automatically start looking within its own internal memory. Wherever it finds that program, it'll start to run that program. Now, if the program exists outside of NC memory, meaning it's sitting on a USB because it was too big to fit in the machine, sitting on a network drive or RS-232, then what you would do is you would use an external call statement, EXTCALL. So if you start to play around with this a little bit and you want to call files that aren't even in machine's memory, you can do that. Just use an EXTCALL, external call. Further down, I change tools again. In this case, I'm using the same tool. I repeated the tool change statement. It's redundant, but when I'm bouncing around, it allows me to bounce a little further down the program. So I can jump over this tool, but still force a tool change down here if I wanted to maybe just jump over to the semi-finishing operation. Same scenario with my finish tool. So there's my finish tool. Now I showed you a couple different ways to call it. I can use the call statement like I did in these next two. And then in there, you type in call, and then in parentheses and then quotations, again, the name of the file. So you can either just write the name of the file, or you can type in call if you like it to look a little more structured. Either way, you'll find we're very forgiving with a lot of type of commands in that way. So we load it up. Down here on the bottom, I'm doing my normal shutdown. Shut off my spindle, shut off my coolant. I'm canceling my tool, so I'm clearing my spindle. I'm disabling my tool offset. I do a quick tool change to actually clear the spindle. I use the SUPA command again to stage my tool, or to stage my table at a safe point for loading, and I shut off my program. So you can certainly simulate these types of programs. If I delete the window and if we were to run again, I can fire it up, and it's going to do everything you saw before. So here it's already in and running the roughing cycle. And then from there, once it roughs it out, it's going to jump over to the other two operations. So even with subprograms, I can still simulate. There, it just jumped over to the other one. Then you'll notice as it gets down past this one, it's going to even jump into the finish cycle. So you still have all that capability you had before. So there we're into the finish cycle. It's rolling around it. Great way to let it run through just to make sure that there aren't any errors or problems prior to physically running the part program. Okay. Now, when it comes time to run the program, I simply go to execute from while inside the main. So this is all our main. So now as I start to run it, I'm going to crank down my override a little bit. See how the current program says surface main? It's telling me where I am right now. As I cycle start and run it, once it jumps in, it's going to always tell you where it sits. So you're never even kind of wondering, gee, which of the subprograms I'm in. Just look at the screen. Right now I know I'm in my Op1 roughing. As I start to crank up my feed rate, as we finish this segment of it, you're going to see it's going to jump over to Op2 semi-finishing, and then even to Op3, the finishing routine. So it's always kind of keeping track of wherever you are at that given point. All right. Oh, hold on. Wait for it to run all the way. There you go. Op2 semi-finishing, and then it goes along. I'm gonna kill it now, because now we're going to bounce around. So let's say, for argument's sake, we were running, we proved out the first two operations, we want to work on the finishing operation, but I don't want to run those cutter paths there. I could absolutely use the block search, like you saw earlier, but what you can also do is you can start to use this go-to statement. So pay note as to where you might want to start from. So I'm going to start from line 210. That's just a quick retract away, just in case I left the tool down. And make sure the spindle's off, coolant's off. It's going to change tools to tool 9, whether it had it or it didn't. And then it's going to load up my cycles and start running. So if you just go to this go-to and change the go-to call to 210, now I'm still running the program from the start. So we're going to hit it right from the start, but watch what happens. It's going to jump right to tool 9, right to finishing, start running the program. You still have the real-time simulation you can bring up if you wanted to. But what I want to do right now is I want to run the cycle and record a cycle time, and then I want to start to show you the result as we start to change the technology within CYCLE832. And what we're going to also do is start to look at some of the commands that are set up and some of the commands that are being triggered. So we have a baseline cycle time for this operation of 7 minutes, 48 seconds for it to run real time on the machine. Now, let's talk and look at what CYCLE832 is really doing in the back end. So when I first start up the program, I'm going to turn on my G-code function panel right here and hit cycle start. And I'm still up. Haven't gone into that program yet. I start to look at it. I have a G64 enabled. That's our base corner rounding function. I do already have some feed forward functions on, so that tells me that the builder, whoever commissioned this machine, wants that running all the time. That's pretty common. I see the G290. I didn't tell it, but it's in Siemens mode, so it's there. I see our dynam norm is sitting at normal, so you're going to see that's changed. And that's about it. Not a whole lot technology-wise going on. So now, as I let the system go in and start running, now some things are going to change. One of the most obvious things I'm going to first see is G645 right here. So that's where it's switched. So the CYCLE832 is what's now triggering a G645 corner rounding function for you automatically. You don't have to know that. What it's also doing is it's also turning your compressor on. That's CompCAD right here. That is what's turning on that spline interpolator. So that's what's taking these points and transposing a spline through them. This is what starts to increase the speed and surface quality and tolerances of the part program as it's running right here. As well, the dyne norm was on before. Now I'm in a dyne finish. That's because I'm in a finishing routine. As you change from roughing to semi-finish to finishes, you're going to see these different statements change, and that's triggering a whole bunch of stuff in the back end. So this is how I can validate that CYCLE832 is actually doing something, because I start to see all these commands being triggered as I go. Okay, so we're 7 minutes, 48 seconds if memory serves me. So what would happen if I was to go into the program and change this CYCLE832 right here for our finishing? So got a couple different options. I could certainly choose a different technology. So we're finishing now. So what finishing means is I'm most concerned about surface quality and part accuracy. And that's why both of these arrows are blue. When I switch it to semi-finishing, I'm not as concerned about the surface quality, but I still want positioning accuracy, but I want speed. Speed starts to become an issue for me. So I'm more concerned about cycle time. And when I'm in rough, I'm really only concerned about cycle time. That's why my velocity arrows map. So if I simply change this to just velocity mode, I don't change anything else and hit accept. And now if we rerun it, let's see what difference we see. Oops. Let me reset this so we get a little bit truer count. So let's see if that makes any change. Some will be more dramatic than others. I'm going to show you in a second. We're going to put a real tight tolerance on it, really choker, and you're going to see it's going to add quite a bit of cycle time. And if I bring up my auxiliary functions and I come down, so we shave 10 seconds off, nothing too dramatic. While I was running, I would have seen the done would have been at rough. So I was starting to see a little bit of a result change. Now let's say I go the other direction and I try to, instead of freeing up the cutter path, I try to really start to constrict it. So I'm going to go back to CYCLE832, hit my recompile, and now I'm going to change my technology to back to finish, but I'm going to cut my tolerance all the way down to a 10th. So now if I go to execute it, and we start to run it, and you're going to see the same kind of results at the machine. And certainly there's going to be a little bit of trial and error. You know, what's the best tolerance that's going to give me my most desirable positioning accuracy and finish? You know, a lot of guys think put as tight a tolerance as I can. Well, that's not always great. A lot of times that will hurt your surface finish because you're restricting the cutter path too much and you get a lot of imperfections in your surface. So now we start to see just from dropping from a half-dot tolerance to a 1/10 tolerance, I went from a 7-minute 48 cycle time to 11-minute 42. So what's that? 4 minutes increased. So on a not even 8-minute cycle time, I took that cycle and almost added 50% to that cycle time. That's quite a bit, especially if this was a 2-hour cycle time. So you're going to start to play around with this. Again, keep the 3 different functions in mind. You know, what I did on mine was I was core roughing it horizontally across the part, so I just let it go wide open with a roughing cycle right up here. So I was using a technology 3, had a wide open tolerance of 5 thou, just letting air fly through it. Then from there, I went into a semi-finishing routine because now I was following the contour, but I was just staying away by a certain amount. I think I left 20, 30 thou on the surface. So now if I looked at it, I was tightening up my tolerance, and I was down here in my semi-finishing. My two lower diamonds were triggered. And then from there, I went down to the full finish. This is where I was really concerned about my dimensioning accuracy and the quality of my part. Okay. So with that being said, I'm going to kind of open it up for any extra questions that may have arisen. I know we're getting close to the hour and a half I allotted. There's a lot of content there. Okay, well, I got some thank yous here from some different people. Oops, sorry about that. Let me any of the questions you guys want to ask, just go to the Q&A panel, and you can type them in here, and we can. I'm just searching through to see if I missed any from earlier. I think we handled quite a few of them. Jog modes. Yeah. Okay. All righty. Like I said, anybody has any questions at this point, feel free to type them in. Here's a question. Was it a different post-processor I used for this as opposed to their 840 control? I did mention that earlier as well, but let's briefly talk about that. It isn't. It was the same post-processor. Certainly some of the critical things that we were talking about was really just those slight machine differences. Be careful, but no, the core code was really the same between the 808 and the 840. Certainly, some of the differences is this a shop mill type protocol that you get in the higher controls. Does NX being Siemens PLM give better results compared to other post processors? Well, I would have to say In some respects, yes. We tend to work a lot closer with NXCAM than what maybe we do with some of the other external CAD/CAM companies. So I think they've gotten the handle down probably a little closer, so there seems to be less hiccups every time a new machine goes in on debugging a post. I do work with those guys quite a bit. So, you know, I work with all of them. So, I mean, I work with guys at SurfCam, certainly guys at MasterCam, and they're all pretty solid. You know, there's always going to be a couple hiccups in the road when you're first, you know, getting that first new system up and going. Okay. All right. Well, I know we went quite a long time, so with that being said, I think we're going to wrap this up now. I want to thank everybody for taking a chance to join us here, and keep looking for some others. I will send everybody out the link to this recording. By all means, you can review it, send it to friends, colleagues, customers. By all means, I'm going to shut off the recording now.